Good morning. What I'm wanting to talk about in this lecture, I really want to introduce you to a new type of archaeology, a type of archaeology that didn't exist at all when I was a student. That's really only become a part of the archaeological repertoire in the last 30 or so years, something that perhaps we just didn't even think about before. And that is underwater archaeology, the archaeology of the seabed. So I'm not talking here about shipwrecks and things. I'm talking about landscapes that used to be dry land and on which our ancestors would have been living, so with archaeological sites, but that have been submerged due to relative sea level rise. And so obviously it's quite a specialized field, finding traces of this archaeology and then putting it together with what we know about life on land. So I want to take you through the ways in which we study it, and some of the archaeological sites that are coming up around the world, just to give you an introduction to this whole new field of archaeology. Right, just work out moving on my slides. That's not doing it. So archaeology is an old and venerable profession. It's been going for a long time. It has got increasingly forensic and detailed over the years. And we obviously are finding out more and more. Any one archaeological site nowadays can give us so much more information. And you might think that we've got plenty to be going on. We know all about archaeology. We know all about what people were doing in the past. We've got lots of sites on land. But actually, there's a whole new world out there. And that is the landscape that used to be part of the terrestrial landscape, but which is now underwater. And places like the Baltic are particularly rich in this. And here are just two slides from sites in the Baltic. Just to give you the idea that I'm talking both about environmental remains, about that landscape itself. You can see submerged tree trunks there, and about the archaeological site, about the human remains and remains of human activities that occur within that landscape. Now, one of the really exciting things about archaeology underwater is that it has fantastic levels of preservation. And we've known about this for a long time. I mean, shipwrecks, they become just amazing kind of capsules where something was stopped quite abruptly. And sometimes the preservation's just fantastic. You can really tell an awful lot about what was going on, about life in the past. I'm afraid to say, if you're interested in shipwrecks, that this is the only slide of a shipwreck that you're going to get in this lecture. So if you're here to learn about shipwrecks, then I'm afraid either stay and have your mind blown by other potential, or you're going to have to hunt out a different lecture. Shipwrecks are interesting, but I want to talk about landscapes. And here you can see again the sort of potential that we can get, not just looking at wrecks, but about these landscapes. They're just as fascinating because we've really got an awful lot of detail about them. And of course, people were living in them. People were participating in activities. You've got communities moving across them. And so here you can see a very basic idea of the sort of thing that you can pull up, just with the idea of the old landscape, now submerged, a paleo lagoon and an old coastline off Rathlin Island. And I just put this photograph in. It's a bit of a bugbear perhaps, but partly because this is a sort of archaeology, that sort of photograph wouldn't have been considered an archaeological photograph when I was a student. You know, it just never occurred to me that I might be going out like that. But the other thing I think is that sometimes this submerged landscape archaeology, I mean, it does involve an awful lot of gadgetry. It involves an awful lot of number crunching. It can get a bit macho. People like showing photographs of themselves with lots of specialized equipment, particularly with a nice icy landscape in the background. And so I just have to put that in to show that even in the UK, it is a specialized field of archaeology, but one that everybody can participate in. Now, one of the best known and the sort of perhaps the landscape that has had the most research done on it, the underwater landscape, is that of Doggerland. And I've touched on Doggerland in other lectures. Doggerland's incredibly important because it's the landscape of which Britain was but a tiny part. When Britain was joined to the continent by dry land, Doggerland is what we call this peninsula off the northwest coast of Europe, which included Britain and which was a whole landscape where people were living, certainly to 7,000 or 8,000 years ago. And so there has been a lot of research done there, and we'll be touching on some of that later in the lecture. But people have known about underwater landscapes for much longer than this. Perhaps hints, in fact, there are even early maps that do show that suggestion of Doggerland. And one of the biggest clues to the existence of these submerged landscapes lay in the many places around the coasts of Britain where you were getting tree stumps and indications that trees had grown in areas that are now underwater. And this is perhaps one of the best known in Britain. This is the beach at Borth in Wales, where there's an extensive forest, and there are indeed human remains and footprints and things. This forest was growing up and into the Bronze Age. And so people were finding examples of tree stumps. There was an engineer, a geological engineer, who was working on British harbours called Clement Reid. When he was working on harbour works in the early 20th century, he would often come across examples where trees had been growing well underwater. And of course, he realised that trees couldn't grow underwater and that this must have meant that conditions were once different. And it's Clement Reid's work, his publications, that really brought the possibility of Doggerland, although he didn't call it that, to the fore in the early 20th century. But in fact, there are people who recorded tree stumps, remains of trees, well back into the 19th century and before. So it's something that we've kind of known about, but we've only recently had the techniques to really look at. And it's not just gone on around the UK. Here you can see fantastic submerged forest. At high tide, this would be under 14, 15 meters of water. This is in Canada, in the Bay of Fundy, just off the coast of Grand Pre. And these really, really massive tree stumps, really quite a long walk out into the intertidal zone, really a most impressive sight. But you don't have to go to very far to discover submerged trees and things. There are submerged forests around the coast of Scotland, certainly in Orkney and off the Western Isles. And I think as we're beginning to understand them better, I know in the north of England, Hartlepool Bay, there's a submerged forest. We're beginning to get more and more examples. And it's really something very special to go and walk amongst these tree stumps and to think, you know, the last person who saw these trees growing probably lived here 4, 5, 6,000 years ago. These trees are, you know, like stepping back in time. So I really would encourage you, if you're visiting the coast places, if you're going to any of the places where there are submerged forests, well worth visiting, something very, very special. And here's just a general picture to give you an idea of the extent of the submerged landscape. Now, this is the submerged landscape, obviously a very rough idea, but right at the height and towards the end of the last ice age in and around Europe and North Africa. And you can see it's really a very extensive tract of land. So we can look at the peoples who are living on the land, on the areas that we now know as land. But I think you get the idea that if we only look at them, then we're missing an awful lot of the picture. But first, in order to be able to really reconstruct that landscape and the landscape change and look at the ways in which it became submerged, because of course, the communities who are living out there, they have to cope with this landscape change. We need to understand why we have a submerged landscape. And put very simply, it's a combination of two factors. One is a drop in relative, in absolute sea level, a drop in the amount of water in the oceans as water is taken up into the great ice sheets that cover the Earth. And it's also the impact of the weight of those ice sheets on the land. So where you have an ice sheet on land, it will depress the land under the ice. That land gradually sinks because the surface of the globe, although it seems nice and firm to us, it's not actually, it is flexible. And the land either side of the ice sheet will rise slightly. And here you can see just a little image to give you that idea, to show you what happens. We call it isostatic depression. You can see the ice sheet forming on the land. The land is pushed down where the weight of ice is greatest. And then at either side, there is a bulge as the land actually rises. You can see that happening if you've got a balloon or an airbed or something. You press down into it and it goes up either side of the pressure you're putting on it. And that's really a very similar thing to what happens on land. And of course, if we know where the greatest weight of ice is, then we can start to do some fancy mathematical modeling and things. We can look at the way that the land would respond to that and see, we can start to reconstruct the bulges either side. And because it's a combination of two factors of changes in the amount of water and changes in the amount of in the height of the land, you'll tend to hear people talking about relative sea level rise. And the reason for this, of course, well, I've tried to set it out in this image here, is that, okay, if the sea just rises as the ice melts and there's more water goes back into the ocean, if the sea rises and the land stays the same, then we have an absolute rise in sea level. But if the sea rises and the land goes up and down as well, then the change can be very different. And that gives us a relative impact. And that's what this image is trying to illustrate here. So I would suggest that you come back and have a look at this image in more detail. And of course, this means that relative sea level, it's not always a case of rising relative sea levels. I think particularly people who live in Scotland, we're very aware that in many places we've got what we called raised beaches, we've got old coastlines, which are now well above sea level today. And so you can get places where you've got relict coastal features that are stranded well above the shoreline today. And one of the best examples, one of the really nice examples, is the Dogstone outside Oban in Scotland, where you've got a nice little sea stack that's now isolated above the shoreline. But there's plenty of other places where you've got old coastal features that now sit above the present height of the sea level. But what I'm really interested in, what I want to talk about now, is the underwater landscape. How can we get a picture of what lies below the seabed? Because of course it's very important to remember that the seabed today, that isn't necessarily a reflection of the landscape. The seabed today may have been scoured out, but it may equally have a lot of deposits, sands and silts and things on top of it. So it's quite a complicated picture to work out what this ancient landscape looked like. And we can only start to think about the people within the landscape if we know about the world they're living in. Now, really, our ability to investigate this landscape, it's really developed in recent decades as we've opened up our ability to investigate the ocean and the ocean floor. And oil technology obviously has been a big driver in that. Oil often taking things at a very grand scale, working very deep. For archaeology, we've kind of narrowed it down and sometimes perhaps working at a much smaller scale, but very often using similar type of technology. And as I say, work does take place at different scales. You can see here work in Rotterdam Harbour, a massive, big floating platform which was used for researching the seabed in advance of extension work on the harbour. And so I think you can get an idea from the size of the crane. You can see some of the machinery, barges, and maybe just make out some people in their protective clothing there. Very, very big scale of work going on there. In Orkney, where I've been doing work, we're working on a very different scale. Very, very small platforms. We've got a little raft that'll only take a couple of people, but it serves our needs. Obviously, we're working in very shallow water often in Orkney. And in fact, that's been one of the problems, that we've had to develop and adapt techniques to work in shallower waters. In places like Rotterdam and many other parts of the world, they've been working in much deeper waters. And many of the techniques that we're using are very familiar to anyone who's interested in the marine world. There's a whole variety of marine scanning and sampling techniques that we can make use of. So some of the scanning techniques that you can see here, very basic sonar techniques, from using Sidescan sonar or Multibeam sonar. That gives you an image of the sea floor and any rocks or depressions. You can build up a kind of topographical map of the sea floor if you like. Then you can use seismic techniques where you're bouncing waves and receiving information from down below the actual seabed. So you're looking either at geological strata that underlie the seabed, or maybe just at different types of deposits and depths of deposits above those geological strata. And then also more recently using various laser, various LiDAR techniques, which can, if you use specific light sources and things, you can get an image that your wavelength will actually travel through water, and that can be very useful as well. And these different techniques all complement each other. So any submerged landscape research tends to use a suite of different techniques. Here you can see the result of some basic side scan sonar, which starts to build up an image of the seafloor, but it's still quite a basic image. Reading it begins to, it takes a little while. You've got sort of objects and shadows of objects and things. Then you can use multi-beam sonar survey, which gives you a much more three-dimensional image of the sea floor. Essentially, it's just a more detailed, instead of using one light source, you're using a lot of light sources. And then you can add on the seismic, perhaps to look underneath a particular stretch of that seabed and see what's going on. And here you can see a seismic section across the depression that's to the left-hand side of the green image there. You can see a little deeper blue depression, and the seismics give us a good idea of the seabed and then the subsea, what's going on under the seabed, the strata and deposits there. And you can use that information to build up an idea. For example, in the previous slide, we were looking for different depths of deposits where it might be worth taking cores to get samples of sediment to study. And so the colored image on the screen, that's the kind of reverse image that's showing you where the deposits are thickest, and we can then decide to target specific sites, put down cores to get sediment samples. And you can see the white markers showing where we're taking our sediment samples. Even having said that, taking sediment samples, putting down a core when you're out at sea, it's not as easy as that. I think quite a few people will have done coring on land, perhaps with someone going out taking cores for pollen analysis or other types of environmental work. That can be pretty hard work. When you're doing it from a moving boat or a raft or something, and you've got to go down 2 or 3 meters of seawater first, it can be even more difficult. But it is something that we can do, and it can give us an awful lot of information. And the other thing is that sometimes we can actually core right on the shore. So here you can see using a little motorized rig to take core samples right just from the intertidal zone. And we can learn an awful lot from these core samples. We can look at things like the salinity. We can see, for example, as a wet area might change from being fresh water to more saline water as the sea floods in. We can look at pollen, we can look at a whole range of microfossils, many of which are very, very specific as to the environment in which they live. And this helps us to build a picture, not just of the landscape, but of the way in which that landscape changed over the centuries, over the millennia, as the sea gradually rose to its present height. And here, taking cores at sea, we've got a little vibro core, so that will vibrate the cores down into the seabed, and then we can slowly winch them out again. But you do, as you can see, you need very calm conditions. So that's another thing. If you're working out at sea, it's a whole new world for someone who's kind of grown up doing archaeology on excavations on land, because at sea, you're very, very much at the mercy of the weather conditions, much, much more so than you are on land. So there's a whole new set of constraints and safety principles and all these things to be learned, working in immersion suits, for example. And even underwater, I don't know if you can make it out, but the divers on the left, they've actually got a little core tube which they're pushing down into the seabed in order just to take a short core. And then on the right, actually having successfully taken quite a long core. So there are different ways that we can get our sediment cores. And then these are some of the sorts of chaps that we're looking at or we're looking for. And any core, when you get your nice big long sediment core, it'll be subsample, different samples from different heights, going off to different specialists. And these are the sorts of things they're looking for. Microfossils, tiny, tiny microfossils, foraminifera, ostracods, diatoms, pollen grains, all these sorts of things, which people are looking for in order to tell about the past environments, and by taking samples at different heights up the core, looking for that all-important change. And we can also put the core through scanners. Here an iTrax that uses X-ray fluorescent. It looks at different elements in the sediment layers, and these provide clues about the past environment. It can give us an idea, for example, when that core was in a terrestrial environment, what were the conditions like? Were they drier? Were they wetter? Again, we can see changes taking place through the core. So there's a whole suite of things we can be doing in order to try and look at the environment, at the world around us. And then more recently, techniques like ancient DNA. This is still something that's very much not under development, I would say. People are beginning to use it much more. It's very specialized, but it can start to give us an idea, much more specific idea, about the animals that might have been around. And so for, in a sort of basic way, passing animals will shed DNA. A lot of that DNA will disappear, but we do get some preservation of DNA. And so if you've got reference samples, if you know what mammoth DNA looks like, or reindeer, for example, then you can identify and pick up if you've got traces of mammoth DNA in your sediments. And start looking for plant DNA as well. And of course, it all goes together to help build a bigger picture. So just to give you an idea of some of the sort of detail that we can start reconstructing, and from one of the very small bays in Orkney. So here in Orkney, we tend to work at a very small scale. We're interested in the ancient population of Orkney and how that population was impacted by the changing landscape of the islands. And over time, the seas have been rising around Orkney since the end of the last ice age. So relative sea level has changed and the islands have slowly been getting smaller. And here you can see just in the bay we're interested in, perhaps during the Mesolithic, you can see there's a very large intertidal zone. That's the pale blue area. You can see that the land or the coast is projecting out. There's much more dry land, and areas that would have been marine or would have held water, the darker blue area, are really very small. And then if we come, and well, just before I leave that, I would say from what we know about our Mesolithic communities, we know that the intertidal zone is very important. So being able to get a handle on ways in which that might have changed and different conditions there and things, it's really very important for us when we're looking at the sort of, for example, population sizes, or if we've got nearby Mesolithic sites, the sort of resources that they might have been exploiting. Coming forward in time up into the Neolithic, farmers arriving, you can see that actually we've still got a very big intertidal zone, and that's quite interesting because the intertidal zone today isn't as large as that. But you can see the way in which, as relative sea level rises, so water is slowly breaching the bay and coming in. What you can also see here that's quite interesting is that sometimes you can get inner lagoons that may remain as fresh water or slightly brackish for longer. So you can have coastal barriers that hold back the sea at a time where relative sea level generally has risen beyond them. And that's the reason why it's always very important to work at this small scale if you're dealing with a particular site or community. You can't take the kind of big, broad scale sweeping maps that are made for, say, the North Sea and apply them to a specific bay in Orkney, because you have to know what the coastal topography is like. And that's the same anywhere around the UK. You can't do it off the coast of Northumberland or the Western Isles or anywhere. You have to know the specific conditions in the area. The broad models will give you an idea of how sea level's rising, where relative sea level might have been, but only by using local topography can you actually look at how relative sea level has changed in that specific place. And so then we come forward into the Bronze Age, and you can see that really the bay is very similar to the bay that we know today. Slightly more extensive intertidal zone, but the main islands have become islands. The coast approximates the coast of today. The intertidal zone's very similar, just slightly larger, much more the landscape that we know today. So it's this sort of micro modeling that's really important if we're to look at how our early communities are living. But of course, we can't always do that. It requires a lot of money. It requires years of very intensive work. And sometimes you're not in by the coast. Sometimes you're out in much deeper water. Sometimes it's much more difficult to access an area that you're interested in. And of course, that is the situation for all the groups like Vince Gaffney and his colleagues at Bradford, who are interested in reconstructing the landscape of Doggerland. It's under much greater depths of water, and it requires much more intensive, long-lasting sea journeys, for example, to go and get those samples. So, of course, it is possible to go and get samples now. There's plenty of survey ships and scientific vessels that you can contract and go out there and take samples. Very costly, very weather dependent. And what Vince and his colleagues discovered or realized was that there are companies who've got all the data that the archaeologists need. And by and large, often these companies, they're not interested in the shallow sort of data, the data up near the seabed that is precisely the material that the archaeologists want. They're often looking much deeper down because they're interested in resources like oil and things. And so Vince, as he's described in his two very good books, they made contact with an oil company. They were allowed to use this high-level data from just below the seabed and the surface of the underlying layers, and doing some clever number crunching and other things, they were able to reconstruct the landscape, initially in a fairly small area of the North Sea, and now they're expanding it much deeper. And they're doing a whole amount of work, adding on coring to get dating samples and things. But I think you can see from the map on the left the kind of scale of topography that they're able to reconstruct. And this is really, really important because it's showing us that Doggerland isn't just some kind of plain. It's not just a featureless sort of flat land bridge or anything. It's an area that has topography. It has features, hills, rivers, lakes, and so on. And of course, as the sea slowly rises, as the coasts disappear, you get the coastline moving in. And so Vince is interested in looking at different areas of Doggerland at different time slices to see how it's changed. And he's also working with colleagues on the other side of the North Sea in the Netherlands and Belgium and other places in order to build up a picture of this changing landmass, if you like. But really, you can get an awful lot of data. There is a lot of data out there. And here you can just see some of the different projects and some of the different work that's gone on around the coasts of the North Sea, just again to give you an idea that we are building up a lot of detail. So you can see, well, Project A is the original work that Vince did, now expanding much more into northern areas of the North Sea. Project B off the in the Bristol Channel, building up some work, looking at a couple of lakes and river systems and things there. And then Project C around the Channel Islands, again, looking at the way the landscape around the Channel Islands has changed very much during episodes of Neanderthal occupation and coming right up to the present day. And from that, people can think about things like, well, what stone resources are people using? Where are people coming from? How are they moving across this landscape? This is all really, really important in order to provide us with a full understanding of the world of the past. And that's what archaeology is all about. But of course, we're not just about reconstructing the environment and the world. We want to look at people. Archaeology is about people. So we want to add people into that picture of the landscape, if you like. Well, from the North Sea, I'll be showing in a minute, there's plenty of human remains that have been dredged up, but by and large, it's very difficult to provide contexts. We have got some underwater sites, but the underwater sites, again, I'll show you some pictures in a minute, tend to be closer into the coast. But what do we do when we're further out in deeper areas? What do we do, for example, for the centre of Doggerland? Well, there are ways we can start to approach it. And one of the ways is to use modelling. Very sophisticated modelling takes place nowadays. People have built up models to look, for example, how do we behave in supermarkets? How do people behave in airports and things? And then that's played into the design of new buildings. You can use the same sort of modelling, looking at human behaviour, looking at hunter-gatherer groups. How do hunter-gatherers behave? What sort of constraints does the landscape provide, what sort of resources, looking at all different things, put that together and start to build what is essentially a mathematical model about people moving within the landscape. But then, of course, nowadays, we've got the technology where we can turn that mathematical model into more of, if you like, a gaming representation. We can actually have images of people. We can put little populations out there. We know what their houses, what their homes would have looked like. We know what sort of structures they're building. We can start to move people through the landscape and get an idea of where they might have been living, what sort of areas would they have been moving through, what sort of pathways would they build up, and things like that. And there's a lot of very sophisticated work going on to do that sort of thing. And so just what I want to do now is really just to, perhaps to pull together a bit more an idea, why is this important? Why do we need to know about Doggerland? Why do we need to know about this underwater archaeology? We've got on very well without it. Why should we start to worry about it? Well, really, Doggerland and then the changes that have taken place in Doggerland over the last 10, 12,000 years, they are vital to understanding the formation of Northwest Europe as we know it today. This is the period when Northwest Europe takes on the shape that we know and love today. And that's why, for me, these hunter-gatherer groups, both the late Paleolithic and the Mesolithic, are so exciting, because these are the communities who are kind of foundational to ourselves today, to ourselves as Europeans. And here I've just put on the screen the very, very first, or one of the very first hints that we had that this was something exciting, something to think about. And this is a tiny flint. I think you can see it as a black dot in the core, in the center of the screen. And it was found when company were taking samples with a view to assessing oil potential and things, found roughly halfway between Shetland and Bergen. And you can see the site marked on the map there. And the flint itself, it came from the sort of upper levels of the core, but it was a little worked flint, a little scraper. And when it first came up, which was in the early 1980s, and I was very lucky to be involved with it, when it first came up, we didn't really think very much about it, just tended to think that it had got dropped off a boat by a modern collector or something, how had it got there? But then quite quickly after, when people began to analyze the core itself, they realized that the area that the flint had come from would have been dry land. And this is still some of the most northern evidence that we've got for possible people moving around Doggerland. Now, of course, you can't populate a whole continent on the basis of one flint, but it was a vital clue to what might be going on. And it certainly started people thinking a bit wider rather than just focusing around the area of the English Channel and the Dogger Bank and things where people had thought before. And so we really can't view the United Kingdom as an island nation. We can't view it in isolation. In order to understand the early formation, the early communities, we have to look at the wider picture. Now, of course, the other thing that we know from the time, and one of the reasons that the sites can be very difficult to find, is that life at the time was so different. I think anyone who's watching this is probably very familiar with Mesolithic, later Paleolithic lifestyles. Communities are very mobile, populations low, people are traveling fairly lightly across the land. The sites can be very ephemeral, often just a few stone tools, perhaps discolorations, concentrations of charcoal, if you're lucky, post holes or something. So these sites are very difficult to find, but they are out there when you start to look. And one of the areas where there has been a lot of research and where some of the first sites came up were around the Southern Baltic. In fact, in the Baltic and north of the Baltic, you've had falling relative sea levels, so that there's land that was once underwater, which is now above the water level. You've got a series of relic coastlines, and you can look at coastal sites that are now well above sea level. But it's a very different picture in the Southern Baltic, where relative sea levels have been rising, and that early coastline is now underwater. And because the waters there are generally fairly low energy, some of these sites have survived in spectacular detail. And so around, say, the coasts of Denmark and things, really some amazing archaeological finds that, you know, as a Mesolithic archaeologist working in Scotland, it's just beyond your wildest dreams to find things like this. Complete bows, look at the bow, and cloth, actual remains of cloth that are, you know, 7,500 years old. I mean, these sorts of things are in fact relatively common from many of the sites that are now coming up all around the southern shores of the Baltic. But, you know, 20, 30 years ago, these were something really amazing, and they still are today. Yeah, excavation taking place at the site of Tubrum-Vig. You can see the familiar archaeological trowel on the left, but often working sometimes with vacuum suction in order to remove sediments and silts and things. And some of the preservation, a double burial site. Around Denmark, there's quite a lot of burials. In fact, also Sweden and Norway being found, because they're very often quite closely associated with settlement sites and things. And so the organic remains extend to the human population too. And obviously that brings a whole other suite of exciting, interesting things we can look at. I rather like this, the paddle on the left, the remains of the blade of a canoe paddle. Now, this is really interesting to me because, you know, we know, even in Scotland, we know that we have Mesolithic sites on islands. We know that people must have had boats. They're certainly able to get out to islands and things. If they've got boats, they must have paddles. They must have a way of moving those boats around. So perhaps you could say, not that surprising to find a paddle, but who would have guessed that they might have decorated their paddles? Look at the artwork on that paddle, and it's not alone. There are other canoe paddles with equally beautiful artwork. So it kind of, this underwater archaeology, it's helping us to add perhaps some of the colour that we're missing from the sites that we're used to on land. And on the right, again, a very sort of ephemeral site, sort of find that we know must have existed, but really exciting to actually find them. Remains of a fish trap from a Swedish site. And there are plenty of other places now where we're beginning to get this sort of detail coming up. Off the German coast, you can see trees emerging, again, a site on the left there, and on the right, again, just the sort of interplay of natural features and artifacts, and antler axe. Now, we've got antler axes from Scotland. We get very excited about them. We don't have any which are found where the haft is still there. And look at this, just lying, almost as if someone's just laying it down to go and pick it up the next day, and then for whatever reason they've forgotten about it. So these sorts of finds, they are really, really special. Moving out from the Baltic, moving over to Doggerland. As I say, material's been coming up from Doggerland for many, many years now. Fishermen had recognized that they were getting bones of extinct mammals. And so here you can see some of the sorts of things that come up in the Netherlands. And it's monitored now, that the bycatch of fishing, mammoth skulls and teeth and bones, all sorts of extinct Pleistocene mammal bone that help us to get a better idea of the landscape that people inhabited. And artifacts, of course, as well. The harpoon head there, this is a a very famous harpoon that came up in a fishing boat, a small trawler, the Kalinda, a few decades ago in the mid 20th century. Really beautiful harpoon head. I think you can see again with some decoration at the end. And then Neanderthal hand axes. And now there's plenty of examples, both of human bone and artifacts and things coming up from all around the shores of the North Sea, as fishermen have become more aware of the scale of things, that they're not just looking for big mammoth bones, but sometimes much smaller pieces, and of the interest of these pieces. But we can move around the world. This isn't something that just happens around the North Sea. And I think, you know, in fact, when you start to look at submerged archaeology around the world, it becomes something where you're not going, oh, this is really amazing. But when you more start to say, why haven't we got it in areas where we haven't yet found it? There are sites all around the world. And what I want to do just in the last 5 minutes or so is just give you a flavour of some of the work that's going on in other places around the globe. And so the Mediterranean, just quickly to look, I mean, this actually is going back much, much further than the sorts of things I've looked at until now. But understanding these changes in sea level and these ancient landscapes, it's particularly important for those people who are interested in movements of early human, in the dispersal of humans, not just in fact in the Mediterranean, but also moving across from Asia into the Americas, across the Bering Straits. These submerged landscapes are crucial areas across which early communities can move. And so there is a lot of work done looking, for example, at these 4 potential dispersal points out of Africa. The Straits of Gibraltar, across the Malta Channel, up in the north of the Red Sea, as Sinai, but also down in the south, down in Yemen. So places where human groups can start to move out of Africa, looking, well, do we have any evidence of that? What was the landscape like? Do we have evidence of early human groups on the other side and things? So submerged landscapes, if we really push them back in time, they also become really interesting for the dispersal of human groups around the globe. But down in Australia, a lot of work now with submerged landscapes, and some of the stories from the native Australians, from the Aboriginal peoples, do relate very much. They tell of a time when sea levels were lower, when the landscape was very different. And archaeological survey beginning to take place here on a rock shelter site down in the Southwest Arm in southern Australia. Here in Japan, again, looking at a shell-midden site at the mouth of a river, all underwater. Sorry, I'm jumping back to Australia. Slide got out. This was the one I was expecting. This is Port Phillip Bay, just south of Melbourne. Again, looking at that ancient landscape, reconstructing that landscape, which once had a big river flowing through it when it was dry land. And again, there are stories of people living out in this landscape, of things going on. So sometimes you can actually use the sort of old wisdom about what the land looked like, and you can start to reconstruct and think about, is it actually telling us about a time when the landscape was different? And we've got examples of that from Australia, from Orkney, from Canada, beginning to be picked up in many places around the globe. Moving over to the United States. In fact, this is an interesting site because this is a freshwater site. The Great Lakes of the United States, again, have seen their own relative sea level, have seen their own changes in water level and lake height. And this is a bison hunting site, one of these traps where the Native Americans were driving animals in order to kill them. and it's preserved on the floor of Lake Huron. And some very interesting work done here using LiDAR, using laser surveys, and then coupling that up with diving and things to look at these sites. Really nice site there. I really like the image of the hunting trap. And northeast Canada, around here, around Newfoundland, Nova Scotia. Again, a complicated picture going on. You can see up in the north of the picture, the relative sea level's been falling, and you've got coastlines, relic coastlines now above sea level. But down in the south, the relative sea level has been rising, and you can see a considerable area of land that has changed. And again, this is area where work has been going on to tie this in with ancient stories from the people who have inhabited the area over the millennia, and some very interesting work being done here. Back into the Mediterranean, Neolithic settlement site with, you can see a well and a megalithic structure. There are houses. There are a whole series of Neolithic settlement sites off the coast of Israel. These sites at the eastern end of the Mediterranean are interesting because very often the sea levels change due to tectonic activity. So sometimes you've got a very abrupt dropping of sea level, and that leads to very specific preservation conditions, sometimes extremely good preservation of built structures and things. But it's not just old sites. We've also got much more recent sites here off the east coast of Germany, a medieval farmstead out in an area that you just can't access today. And it was an area that there are stories of big floods and storms and silting going on, and the landscape gradually became unworkable. And you can see in this satellite image the farmstead showing up. And in fact, you can just go on to Google Earth or some of the other big good satellite sites and play around in areas, and you can find submerged sites, which is really exciting. If the satellite happens to be passing at a time where the tide is low or sea conditions are particularly clear and still, you can start to find sites. So here, being able to use it to access sites that are almost impossible to reach on land. And off the coasts of Brittany, the Morbihan, we're jumping back in time to the Neolithic, but a nice stone circle site. In fact, there's another circle next to it, which is completely underwater, the site at Erlanique, where relative sea level has been slowly flooding the site. So I think you can see that there's a whole range of material, sites of all ages, some of them quite easily accessible. You could walk to this site. It's on a small island, but some of the sites we can actually see the sea level change taking place. Other sites we can only see remotely. Some sites we have to dive. Sites like Boldner Cliff, a nice Mesolithic site off the in the Solent. Other sites we can only look at through the sort of scanning and remote sensing equipment. But really, there's a whole range of sites. There's a whole landscape out there that we're only just beginning to come to terms with. At the moment, it's still very slow. We're still developing more and more refined techniques of learning about it. But it's perhaps one of the last frontiers of archaeology, a whole sort of world that we're only just beginning to explore. So again, if you're just starting out in archaeology, it's not a profession where you're just kind of adding little bits here and there to existing knowledge. There are places where you can really go out there and really make a contribution. Thanks.